Hi everyone, my name is Chuck Connor. I'm a professor of geology at USF. This summer I had to teach a field course to geology majors. It's a capstone course in which normally students go out to Idaho with me and learn how to map geology. And since that wasn't going to work at all, we had to develop an online version of the class and teach it remotely. And so I did that, and the course centers around a series of 5 or 6 web pages, and I'll show you a few of them as we go through it. But I just wanted to mention that one of the first ideas we had about the class is that we had to teach it in a way that students didn't feel like they were missing an experience. Well, they were missing an experience. They weren't out west seeing that geology. So what we did instead was develop these web pages around very remote areas. So this exercise, for example, which is one of the first that the students encountered, was about Mount Cleveland volcano. It's a volcano located in the Aleutian Islands. Students aren't likely to visit it. You can only get there by helicopter or boat, and we decided they would explore Mount Cleveland and not feel like they were missing out on the experience of actually being there. And other field areas were in New Zealand, Japan, Mars, all areas that not involving things that students would normally do in person. Okay, another aspect of the class is we developed the web pages to be self-contained. And the idea behind the self-contained web pages is that students would be able to interact with the web page in ways that we thought were creative. They would have an experiential approach. That is, they would try to use tools both on the web page and tools that the page directed them to, like Google Earth and the Smithsonian Institute website and things like that, where they could explore information and data to solve actual problems. So in this case, we wrote a JavaScript tool for looking at map bearings and understanding how to find map bearings. And the students were asked to load specific bearings into the analysis and try to locate where a webcam station would be located. And then they further looked at the analysis of instrumentation called infrasound in order to get an idea of how bearings are used by volcano scientists to locate the source of volcanic eruptions and that sort of thing. So the pages were fairly elaborate, but we were able to put them together relatively quickly. And the idea was simply to give them the experience of working with real geologic data in a fairly controlled environment, which was the web page that we created. I think it's important to realize that although the web pages themselves could be worked through asynchronously by students, we'd start each class by going through introductory material online synchronously with students. We would ask them to participate by interacting with us and loading the web page and discussing some of the content on their own, ask them a lot of questions. And then they went off and did the exercise. And then my TA and I spent quite a lot of time online, sort of an open door to Blackboard Ultra, and students would periodically check in and ask questions about the material. And that seemed to be very effective. Students were able to feel engaged. At least in my opinion, they felt engaged because they needed to use the material I was talking about at the beginning of the class to answer questions about the web page. They could go through the web page even as I was speaking, and that helped them focus on what information they really needed in a sort of on-time learning fashion. And then we were able to answer questions to them that they might have had. The JavaScript and leaflet tools were super helpful in order to construct web pages that were quite specific to our geology students in our class, and I think students appreciated that the material was built for them. Just to give you an idea of some of these tools, for geology we use a lot of remotely sensed data, and so I made the point to students that in the field they would normally zoom in on an area using remotely sensed data, like the crater of this volcano, and learn more from the remotely sensed data than they might learn on the ground anyway. And so I wanted to emphasize for them that they weren't getting an experience that was instead of the much better experience of doing field work, but rather a tool that they would use in their toolbox both normally and when they began to use these data to solve an actual field problem. So that was pretty fun, and students seemed to enjoy getting out of their space wherever it was and exploring the Aleutian Arc and other areas as well. And then a final point is that rather than focusing so much on the process of making geologic maps per se, we actually were able to focus quite a lot on what people use those maps for, like in my case, for determining the volumes of explosive volcanic eruptions and that sort of thing. So we gave them a lot of examples of past eruptions. We went through simple exercises for how to model those eruptions and to understand things like their volume and intensity, other parameters that geologists care about. And that involved quite a lot of computation. And so we developed some tools to help them with computation, like this one. This is a bubble map of the thickness of volcanic ash that accumulated on the ground after an eruption in New Zealand. And they could drag around a tool and determine the area enclosed by specific parts of the deposit based on the thickness of the deposit. And when they did that, they would get the area in square pixels, and they had to go through a process, fairly involved process, to turn those pixels using a map scale that they derive into square kilometers, and then to convert those data to volumes. And so they used, we went through in a very practical way, trying to get them to do those kinds of calculations. So I'd say some of the lessons learned were, wow, I was shocked at how many students had technological problems, both with the internet. I mean, we could, this will work in any web browser, but students had to attend class, for example, by going to other people's houses to log into the internet. We had students who apparently became homeless during the term this summer and things like that. So the technological situation for our students and the access to simple technology like the internet should not be taken for granted. So in our case, what we did is we made a very open-ended policy on when things were due and encouraged students to take advantage of a variety of resources that they could find accessible even in this situation. So that's it, and I hope it's helpful.